our graph at? Very good. So we started with a point at -2, and then my slope tells us to go where for our next point? Where? Up 1/1, right? There's no negative there, so it's just like a +1, okay? So I put all my points on here. Okay, looking at the inequality that was given to us, are we going to have a dotted or a solid line? Dotted, good. And do we want to shade above or below the line? Above. So I'm shading up here. Okay, and then they ask which one of these coordinate points is a solution to our set. So we're looking for the coordinate point that falls in our shaded area. And which coordinate point is that? So -3, -5 is right here. That's outside of the shaded area. It's not that one. There we go. -2, +3, right there in the middle of all that shaded. Okay? All right, so keeping that in mind, what we said the solution was, we said basically your solution is where it's shaded, right? It has to intersect with the part that you have shaded. Today, we're going to be talking about solving systems of equations, still by graphing, so we're still going to graph them, but today we're not going to have to shade. We're just going to graph two lines and see if they intersect or not, okay? So, it says here, a system of equations is two or more equations that you're trying to find some solution to. So remember, a solution is going to be some ordered pair, like what we had up here, some coordinate point x and y. So it says here is an example of a simple system of equations. We've got x plus y equals 5, and x times y equals 6. It says solving a system of equations like the one above means you have to find an x and a y value that's going to make both of these true. So you have to pick a number for x and a number for y that will work in both of them. Okay? So I need to pick something for x and something for y that when added together give us 5. So what's something that adds together to give me 5?
2 and 3.
2 and 3, right? Also 1 and 4, but we have to keep in mind it's got to work down here too, right? Is 2 times 3 6? But is 1 times 5 6? No, so it has to be the 2 and the 3 because that's the only one that works in both, right? So we could say that our x is 2 and our y is 3, and it's going to satisfy this system of equations. You would just then make sure that you write your answer as an ordered pair. So remember, we put x first, then y. So it would be the ordered pair 2, 3. Okay? All right, so in the next section, it says tell whether the ordered pair is a solution to the system of equations. So they give us the coordinate point. In a coordinate point, we said that the first number represents what letter? What letter is that? X. The second is, so that means I'm going to just plug those in and see if they work anywhere there's an X and anywhere there's a Y. So for this first equation, I'm going to rewrite it exactly as it is. So I've got -3. But what did we say we want to replace the X with?
2.
Good. So -3 times 2 plus, then we've got 2 times, what do we want to replace Y with? Good. Is supposed to equal -4. So let's see if it does. So what's -3 times 2? Good. Plus, what's 2 times 1? Good. And what's -6 plus 2? -4. So did it work? Does -4 equal -4?
Yes.
Okay. So it worked for the first equation. This one's all good. Now I just need to double check that it's going to work in the other one as well. Okay. So we said we replace x with 2, right? Plus replace y with 1. And it's supposed to equal 3. Does 2 plus 1 equal 3? Yeah. So it did work for both of them. So my answer is yes. This is a solution. Okay? We're going to do the same thing on that second example. So again, remember these are our x's and these are our y's. We just need to substitute those in. So in that first equation, I've got an x. What am I replacing it with? Good. Minus, what am I replacing y with? Good. Equals 7. So we've got negative 3 minus negative 10. Minus a negative becomes a, right, so I really have negative 3 plus 10. And what is negative 3 plus 10? So this one works, right? All right, now just double check the next one. 3 times, what do I replace x with? Negative 3, good. Minus y, and what do we replace the y with? Good. Is equal to negative 19, right? Okay, so now we need to simplify. What is 3 times negative 3? Good. And you guys already told me 2 negatives in a row make a positive. What is negative 9 plus 10? 1. Does 1 equal negative 9? No. So this one didn't work, so no, this one is not an answer for us, okay? So, if you notice here, our answers are always going to be some coordinate point. That's what we were checking to see if it works. So, if you are given 2 equations, let's say they don't tell you what the coordinate point is. They want you to figure it out. That could be kind of hard, depending on what the numbers are, for you to just guess and pick the right one, right? So we have a few different methods for figuring out what that coordinate is. The first one being to solve by graphing. Okay? We're just looking for where these might intersect. So, it says to solve this system of equations by graphing. So my first equation, is it in y equals mx plus b form? Yes. Okay, so let's go ahead and graph it. Where am I going to start at? Negative 1. All right, and then my slope tells me to go where for that next point? Down 2 and over 1. Good. All right, and this doesn't have an inequality, so I don't have to worry about a dotted or solid line or where I'm going to shade. All I have to do is draw the line. Okay, the second equation, is it in y equals mx plus b form? Yeah, so it's ready to go. Where is that one going to start at? Positive 3, good. And my slope tells me to go where for that next point? Good. So, did our 2 lines cross? Yeah, right here, right? Where is that coordinate point right there? Good. So that is my solution. Okay? If you wanted to check it, just like we were doing the ones on the front, you would just plug in the negative 4 for x and the 7 for y. So in place of y, we would have 7 is equal to negative 2 times, replace the x with negative 4, minus 1. Well, what is negative 2 times negative 4? Positive 8, good. So I'd have 8 minus 1. What is 8 minus 1? Okay, so it works, right? 7 equals 7. And then you could check it in the other equation as well. So you'd have 7 is equal to negative x, which is negative 4, plus 3, Well, you guys told me two negatives make a positive. So I have 7 equals 4 plus 3. Does 7 equal 4 plus 3? Yeah. So it did work for both. So if you just graph your two lines, wherever they cross, that's going to be your answer. You don't have to work it out like this every single time. Okay? So therefore, the solution to a system is always going to be some coordinate point where the two lines intersect. So from now on, if we can just figure out where they intersect, we don't have to go plug it back in like we did here. Okay? All right, let's look here at number 3. Okay, on number 3, is this equation ready to graph? No. So we've got 2x plus y equals 2. What do we need to move?
2x.
The 2x. How do I move it? Right. All right. Can I actually subtract 2x from 2? No, because they're different, right? So I just write down the negative 2x and then the positive 2. Okay, so now this one's ready to go, right? Where is it going to start at? Positive 2. And my slope tells me to go where for that next point? Very good. Okay, so there's the first one. That second equation, is it ready to graph? No. So what do I need to move on the second equation? The x again. So I've got to subtract x from both sides. And I've got negative y is equal to, again, we can't put them together. So just negative x plus 4. And we can't leave that negative in front of y. How are we going to get rid of that? Divide by negative 1. Very good. So I got to divide everything by negative 1. So that makes the negatives go away. That's going to do the same thing to my x, right? It's going to make it a positive x. But my positive 4 is going to become negative 4. Good. Okay. And now this one's ready to graph too. So where is this one going to start at? Negative 4. Good. And my slope tells me we're going to go where? Nice. All right, so do our two lines cross this time? They cross? Yeah. Right here at this point, right? Where is that coordinate point at? Other way around, but yes, positive 2, and then to the y you move down to. Good. So 2, negative 2. Nice. So that's my solution. Okay. All right. We got one more on this page. Okay, is it ready to graph right now? No. Okay, so we got x minus 3y equals 6. What do we want to move? X, okay, so we're gonna subtract x from both sides. So now I got negative 3y equals negative x plus 6. Then what should we do? Divide, good. So I divide everything by negative 3. Okay, I can't divide x by 3, but what's the secret number that's there in front of x? 1. So I've got negative 1 divided by negative 3. I can't actually divide them because it's going to give me a decimal, but two negatives do make a right. So we've got positive 1/3 x. And what's positive 6 divided by negative 3? Negative 2. Good. All right, so now this one's ready to graph. Where is it going to start at? Negative 2, very good. And that slope tells us to go where for our next point? Nice. Okay. All right, for that second equation, that one's probably not ready to go just yet either. So what are we going to need to move on to that second equation? The x, right? We're going to move the x again. So we got negative 6y equals negative 2x minus 6. Then what should we do? We do need to get rid of the number in front of y, but it's not being added to y. We need to divide it, right? So I'm going to divide everything by negative 6. So, negative 2 over negative 6. We know two negatives are going to make a positive, and what's that going to simplify to? So it's two negatives. So it is positive 2 over 6. Will 2 over 6 simplify any? So remember, we can just divide 2 by 6 in our calculator, math inner, and it tells us 1 over 3. Very good. Okay, and what's negative 6 divided by negative 6? Good. All right, so where is this graph going to start at? 1. And it goes where for the next point? Nice. Right. Okay. So, do these two lines intersect? No. Are they ever going to intersect? No, because they have the same slope, right? So I don't have a coordinate point where these cross. So my answer in these cases are no solution. Remember that there's a symbol for no solution. It's that 0 with the line through it. You can use that as well. So we'll know that this is going to happen in cases like this where your slope is the same. So anytime you have the same slope, this is going to happen. Okay? Because we know that parallel lines never intersect. Okay? Okay, we got one more example on that last page to graph. So if you'll flip it over onto the back, for this last one, that first equation, not quite ready to graph, what are we going to do to solve? Yes, we need to put it in y equals form. So what should we move first? The x. Very good. So I've got negative 2y is equal to negative x minus 8. Then what should we do? Get rid of that negative 2. Yes, we can divide. All right, what's that secret number in front of x? 1. Okay. And a negative 1 divided by a negative 2 is going to become positive. Good. So we'll have positive 1 over 2. And what is negative 8 divided by negative 2? 4. Good. All right, where does this thing start at? Positive 4. Good. And my slope tells me to go where? Good. Okay. Now I just need to fix the second equation. So what are we going to do on this one? what should we do now?
Take away that 6
Right. We got to divide everything by that -6. All right. So -3 divided by -6. Remember, we can put it in our calculator. It'll tell us what it simplifies to. 1/3. Good. Oh, sorry, 1/2. And then what is -24 divided by -6? +4. So what do we notice? It's the exact same line, right? So here and here is the same line. So if I go graph this one, every single point lands on the points that are already there, right? So it doesn't just touch it at one point, it touches it at all of the points, right? So instead of just having one coordinate point as my answer here, I could write a million different answers there because it's touching the line at every single coordinate, right? So my answer in these cases are infinitely many solutions. Okay, so keeping that in mind, when we had a system of equations that we graphed like on numbers 2 and 3, what did our answer look like? What was our answers on number 2 and number 3? -4, 7, and okay, so they're just a coordinate point, right? So if they are just going to cross in one place, like those do, then we have a solution because our lines intersected in one spot. Okay, on number 4, on that one we said there was no solution. What kind of lines did we have on number 4? Parallel lines. So if you have parallel lines, your answer will always be no solution. And when we have infinitely many solutions, what kind of lines did we have? The same line. Good. The lines are the same. So if your lines are the same, it's always infinite. If your lines never touch, your answer is no solution. Otherwise, it's just a